Welcome back. This is part 2 of the Ecart review problems, and I'm going to start right in with number 7. So number 7 is an absolute value as well as number 8 was, but it has an inequality. So we still have the same steps where we're going to isolate the absolute value, write two equations and solve and check, but this one is obviously a little more complicated than number 8. So our first step is needed. We do have to isolate the absolute value. So to isolate this absolute value of x plus 2, my first step is going to be to add 5 to both sides. And then I have 2 times my absolute value of x plus 2 less than 14, because that will go to 0. Now I have to still isolate the absolute value, so this is 2 times it, so I have to divide by 2. So this 2 divided by that 2 will be 1, and 14 divided by 2 will be 7. So we have the absolute value of x plus 2 less than 7. And that was all step 1. So we finished step 1. Now we have to write our two equations. When we have inequalities, we have our first equation is going to be what it looks like there without the absolute value. So x plus 2 less than 7, and x plus 2, the second equation, the inequality is going to flip, and then we're going to write a negative 7. So we'll solve for x now. We subtract 2 from each side, and we get x is less than 5, and x is greater than negative 9. Okay, so let's graph it to see if this will be an and or an or. If we have an x value less than 5, we'd have an open circle on our graph because it's not less than or equal to, so it doesn't include 5, so it's going to be going this way. Less than 5 would be all these numbers here. And it has to be greater than negative 9. So I'm already, just by starting to graph it, I'm already realizing this is an and. So it have to be all of the numbers inside here. But it would not include negative 9, but it would include everyone all the way to 5, but not 5. So that would be our graph. Our set notation, when it's an and, we can combine it. If this was an or, if we had the opposite situation where our arrows were going the other way, then we couldn't combine in set notation, but it is an and. So 2 ways you can do that. You can not combine it, where you have the set notation has the variable such that, and just write them both in there. And that's always the safest. If you're not sure. So an and you can write in, or the other one you can say, I guess I'll write it below because of the other problem. So x such that x is less than 5 and greater than negative 9. Okay. Now for interval notation, we're just talking about the values on the graph. So it starts at negative 9 to 5, and they would be parentheses because it does not include negative 9 or 5. If this was solid and it was a less than or equal to, we would put brackets. But in this case, it doesn't include those two values, so it's all the numbers in between. All right, for number 9, we're going to isolate our radical in this case. We're trying to, every time we're solving, we're trying to get to the variable. And this time, x is surrounded by the cube root. So we want to isolate here first. I got to add 5. And we have the cube root of x equals 27. Now, this really means x to the 1/3. So the only way to get x by itself is to cube both sides. So that will cancel out the cube root, and it won't change the problem. So x will be by itself now because that cancels that. And then 27 cubed, that's a huge number. Let's use the calculator. And we get 19,683. And again, make sure you're checking with all these steps, so you would plug that in to check. Okay. And that's our answer. All right, let's look at number 10. So number 10, remember from our unit 4, we're solving quadratic equations, and we have lots of options here. You have graphing, factoring, or the quadratic formula. You can also use completing the square, and in this case, it turns out it's not factorable. First we have to set it equal to 0 before we can solve, and we'd have to subtract 5 from both sides. So 4 minus 5 would be minus 1. And then when I went to try to factor this, it's not able to be factored. So this is prime. So then I had to make a choice between the quadratic formula and graphing. The quadratic formula is always given to you. So I want to show that method. So the quadratic formula, remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And when you're using that to solve, remember the good first step is we're going to write our a, b, and c. So our a is 3 in this case, our b is 4, and our c is negative 1. And then we're going to take those values and plug them into our equation. So x would be equal to negative 4 plus or minus b squared, so 16, minus 4ac, so 4 times 3 times negative 1, all over 2a, so 2 times 3. Okay, this is an exponent of 1/2, and what a square root means. So we have to simplify this first, and we have 16 minus 4 times 3, which would be 12, times a negative 1. So negative 12 times negative 1 would be plus 12. So we have 16 plus 12. So that's 28. 2 times 3 here is 6. So negative 4 plus or minus the square root of 28 over 6. 28 has a factor of 4 in it, so we can take the square root of 4, and that would be negative 4 plus or minus 2 times the square root of 7 then. And then we could factor out a factor of 2 to simplify. And we would cancel that factor with a 2 that's in the 6. And our final answer would be negative 2 plus or minus square root of 7 over 3. Now, if we plug this in the calculator, we get negative 1.55 and 0.215. And the reason that I show you that is some of you might use the calculator to get your zeros. And I will show that next. But if you do that, sometimes the Ecart will represent it in radical form. So you need to realize that if you see all of the answers in radical form, you want to do the arithmetic in the calculator of negative 2 plus square root 7 divided by 3, and that would be 0.215, and negative 2 minus the square root of 7 divided by 3, and that would be negative 1.55. And to show you how to find these same values, so again, you're wanting to, if you find them this way, you would go through your answer choices A, B, C, and D and see which one would be equal to these. If you're using the calculator to do it, then remember you put your function in that's set equal to 0, so our quadratic 3x squared plus 4x minus 1, and then graph it. And you're looking for these 2 points. Our solutions of our quadratic, or one item, is the x-intercepts. And in this case, let's go ahead and find the one on the left here. So you hit second trace for calculate, and then go to number 2. And let's find this 0. There's 2 of them we can find. And the first one I want you to find is this one. And you want to go to the left of that 0. So the graph is always analyzed from left to right. So for this 0, the left is here. And we hit enter, and then past it. And then that would be to the right of that 0, and we hit enter. And then you guess by bringing it close to that spot and hit enter. And you can see we have negative 1.55 if we rounded up. Okay. Go ahead and try the second one if you need to, and make sure you get 0.215. Okay, so there's some questions here that we need to make sure we understand. So the solutions are negative 1.55 and 0.215, but again, they might be shown in the radical form, so a lot of times they'll combine that. If x equals negative 2 plus or minus the square root of 7 over 3. And they could separate them as well. So there is 2 solutions. And there's also, remember, roots are can be imaginary or real. So, and roots in this case are real, and they will be the solutions here. So it would be 2. If there was a negative sign under our square root when we did the quadratic formula, then they would be imaginary. But in this case, our roots and our solutions are the same thing, and they would be real. Okay, let's look at the next problem. And this one is solving systems. So there's 2 ways to do this, either graphing or by using algebra. So the first way, if we're going to use graphing, we want to set them equal to y. So for our line here, we're going to subtract 2x from both sides, and we'll get our line of negative 2x plus 5. And then for our parabola, we're going to add x squared to both sides to get y by itself. And there's we have a line and a parabola. And let's plug them into our calculator. So you can't use your calculator unless they're both set equal to y. So our line and our parabola. And remember, this would be a line with the intercept of 5 with a negative 2 slope, and a parabola going up. And let's make sure it comes out the way we expect. There's our line, and there's our parabola. And I can see visually that there's 2 intersections. Remember, for a system, it is the intersection of the 2 things. It's not the zeros that we're used to finding solutions, but for a system, we have 2 different things. We're looking for where the points of intersection, what would make a true statement for both items. So there's a point here and a point here that would be the intersections. And we can solve that again using intersection. So second trace, and then intersect our first curve and our second curve, and then a guess, and there's our first intersection. And then if we found the second intersection, we would do the process again and just make sure it's near the other section. And it gets negative 2,9. So that's what you do, and these would be your solutions.